Hello everyone, we're going to be talking about multiplying and dividing radicals with variables and cubed roots. So we'll be talking about changing that index to 3. So for the first thing, I want you guys to be sure to identify each expression is rational or irrational. So that's going to be for every single problem. You're going to make sure that we identify our final solution as rational or irrational. Our steps to multiplying radicals: we're going to first work with the coefficients. That's going to be the number before the radical sign. Then we're going to work with the radicand, the number inside, the values inside the radical sign. Then we're going to simplify if possible, and then we're going to state if it was rational or irrational. So we're going to go ahead and go over an example first. And our first example we will be doing is we are going to be taking 5 square root 2, and we're going to be multiplying it by 3 square root 3. So if we look back at our steps, it tells us to work with our coefficients first, which is the number in front of the radical sign. So if we do 5 times 3, and then we work with our second step, we're going to work with the radicands, the number under the radical, so then that's these. We're going to square root, and then 2 times 3. So now we're just going to go ahead and simplify. That was our third step. 5 times 3 is 15, and then 2 times 3 is 6. This is our simplified value. We cannot take the square root of 6. We break it down as just 3 and 2. There's no perfect squares to actually break that down, so we can no longer break it down, and we leave it as the square root of 6. For our second example, it's going to look like this. We have parentheses 3 square root 7 squared. And what this squared means is that we are writing this entire value twice. So we are multiplying it by itself, just like we have if we had our value of 4 squared. That means that we are doing 4 times 4. So we're going to do the same thing here. We're going to do 3 square root 7 times 3 square root 7. And we are going to work with our coefficients first, so 3 times 3. And then our radicands second. So 7 times 7, so we get 3 times 3, which is 9, and then 7 times 7 is 49. And before you guys we multiply that, we actually saw that since we have a square root, an index of 2 here, then we're actually looking for pairs. Well, we saw that we actually had a pair from the beginning, so I didn't have to technically do this step because I know I have a pair of 7s, which means that this pair of 7s is going to join those 3s. So again, if you broke this down, it would go right back to 7 and 7. A group of 7s goes out front, so we actually have 9 times 7, and we are going to just multiply that to get 63. And that is our final answer. And guess what I already forgot? So this has a radical symbol. Remember our step number 4, I said for all we're going to state if it's rational or irrational. Since it has the radical symbol, this is going to be an irrational solution. And then this one, since it was just a whole number, this is a rational solution. Okay, so then our next example we're going to get a little bit more difficult, 6 square root 9 n squared, and then we're going to multiply that by 3 square root 24n. So I would like to break these down first before I start multiplying things. So I'm going to see, I know that this is, so 6 is going to say out front, we have the square root of 9 times the square root of n squared. You guys don't have to do this step if you already see that it's the square root of 9, which is 3. So now this comes down, it's going to be multiplied by 3. And then n squared, we have 2 groups of n's, so that means that we have one group of n coming out in front, and, we have one group of n, but we have 2, it's n times n, which is n squared. And also, you guys, I didn't remember telling you this, so I'm going to tell you now. The square root and the squared are actually inverse operations of each other. I will go into more detail of that later, but for now, we are multiplying all those together. So 6 times 3, we get 18, and then times n. Now I'm going to go ahead and break this down. We want to break it down to our perfect squares if we see them. So my perfect square would be 4 times 6. So I know that the perfect square root of 4 is 2, so now I'm going to have 3 times 2. And then the 6 gets broken down to 3 and 2, but I can't actually have any groups with that under the radical. these are out front the radical sign, so we can't do that, so we have to leave the square root of 6, and also the n only has 1, so it can't come out front. So we have 3 times 2 is the square root of 6n, and so now I'm going to multiply 3 times 2, which is 6, and then 6n. So now I am here. This is not my final answer. I now need to multiply my coefficients, which is the 18 times 6. So now we get our 108, and our n is in the front. We've already broken down the radicand, so that's our final answer now is 108n square root of 6n. And this value is irrational. Okay, and then our last example for our just doing the differences of the multiplying. So now we're going to add a cubed root, which means my index is now 3. Make sure it's a mini 3, you guys, times the cubed root of negative 8. So we were being able to break this down. We were breaking it down to a perfect square. However, my index has changed, and I no longer have to look for pairs of 2. I have to look for groups of 3 now. Since I don't have a group of 3, this is going to stay as the cubed root of 4. And we want to check to see if I could break this down. This is 4 and 2, which means that 4 gets broken down to 2 and 2. And it has to be this, these are negatives because we will have negative, we need a, oh sorry, wrong thing. We only need one of them. So 4 times negative 2 would get us to negative 8. Then when we break down this 4, we need a negative 2 times a negative 2 gets us back to positive 4. And then now all of a sudden we do have 3 negative 2's. Remember the index, we're looking for groups of 3. So I'm going to multiply that, bring that negative 2 out front. I have nothing left over in the radical because I was able to circle everything under that radicand sign. And so now I'm going to work with my coefficient. My coefficient is the only negative 2 that I have out front. And then I'm going to have the cubed root of 4 because that was not able to find a group of 3. So I now have negative 2 cubed root of 4, and this value is irrational. Alright, so we are going to now talk about dividing our radicals here. And our first step for dividing radicals, we're going to simplify the fraction. And then sometimes it might be easier to take the radical first of each before actually simplifying the fraction, so we'll have to get used to that. Our second step is to actually take the radical. Our third step is to simplify fractions outside the radical, which are the coefficients, and then simplify our radicands, and again we are going to state if our solution is rational or irrational. Okay, so for our first example, we are going to take the square root of 30 divided by 24. So this is a large square root over both the fractions, both numerator and denominator. So in this case, it is actually easier to take the simplify the fraction first. So I know that 6 goes into both of these, so I'm going to divide both the numerator and the denominator by the 6. So 6 goes into 30. Don't forget your square root. We haven't taken it yet just because we're simplifying the fraction. 30 divided by 6 is 5. And then 6 goes into 24 4 times. So now I've simplified my fraction. I am now going to take the square root of the numerator and the square root of the denominator. So if you work with them separately, I see that I am unable to take the square root of 5, so I'm going to rewrite the square root of 5. However, I do get to take the square root of 4. I know the square root of 4 is 2. So that is my final solution. I am unable to simplify anything else, and I know that it is irrational because I have that radical symbol. For our second example, we're going to throw some variables into that. So we're going to have the square root of 30x to the 5th power. We're going to divide by 10x. We are going to start by simplifying our fraction first. So 30, actually 10 goes into 30, so I know that 10 goes into 10 once, 10 goes into 33 times. So I'm going to rewrite this radical, and we get 3 divided by 1. And then our x's, you have to think of, okay, we have 5 x's on top and 1 on bottom, so how many are going to divide out? We get 1 that divides out, we're left with 4 on the top, so we have x to the 4 on top. Okay, anything divided by 1 is just going to be itself, so I'm going to simplify this down to 3x to the 4th power. And now we just need to simplify our radical. I am unable to take the square root of 3, so I don't get to do that. And then I do see that I have 4 x's under here. I'm looking for groups of 2, which means I will have 2 groups of x's coming out, and then I am left with the square root of 3 under there. So x squared square root 3 is your solution to this expression. Simplifying our rational. Oh, and we also, it is irrational. Okay, and our next example, we have the cubed root of 120 divided by 27. Again, we are going to try and simplify our fraction. And I know that 3 goes into both of these. So I'm going to divide both the numerator and denominator by 3. We're going to have our cubed root. Don't forget to write that little mini 3, you guys. That changes the entire problem if you forget that. So now I have 120 divided by 3, which is 40. And then 27 divided by 3 is 9. So now I'm going to go ahead and take the cubed root of 40 as well as the cubed root of 9. So again, 9 is not a perfect cube. It is a perfect square, but it is not a perfect cube. So that means I am not able to simplify that. However, that cubed root of 40, this is a case, you guys, where it would have been easier to actually take the cubed root from the beginning. So let me show you this. I'm just going to pause right here because this will be tomorrow's notes on where we will be going with this. However, if we were to actually take from this first step here, if we were to take the cubed root of 120 divided by the cubed root of 27 at first, then, let me use a different color, then we were actually able to find those values. So we're trying to figure out what number goes into 120, or if you just do some side work over here, I'm going to now break down the cubed root of 120. So I'm looking for groups of 3 here. So if I break this down, I know that it's 12 and 10, and then I have, I'll just do 3 and 4 since I'm running out of room. And you guys can break it down using either numbers you'd like. So now I'm looking for groups of 3. You're going to only use the prime numbers, the numbers that you have in the last row. You're going to ignore these ones, the numbers that you broke down. So I do have a group of 3 here. And that means that a 2 is going to go out front, and then the remainders that I don't have, those circled ones that don't have little buddies to go out for that cubed root, are going to multiply inside. So 3 times 5 is 15. Now I'm going to do some more side work over here. I'm going to take the cubed root of 27, and I know that we have 9 times 3, and then 3 times 3. So I have a group of 3 here. So that means that on the bottom of my fraction, I have a group of 3, nothing left over in that cubed root because I was able to find a group of 3. And this is actually your final answer. You cannot divide these two things because this 3 is outside of the radical and that 15 is inside the radical. So that is our final answer, and that is it for our notes today. I will see you guys in class.